Hi there! It's been a while again. Apparently it's becoming a pattern here to have a video every half year or so. This one's about a guitar preamp or headphone amp. I mean, mostly I just wanted a way to listen to my guitars without having to hook them up to the computer. And also, ever since I had my first guitar with more than one pickup, I've always thought about the possibilities of processing and mixing all the pickup signals individually outside of the guitar to achieve all kinds of strange and interesting sounds. This project addresses the first part while also being part of the second. The housing I will be building the amp into, as well as some of its connectivity, are intended for that purpose. First though, I'd like to talk about why we even need a preamp or headphone amp in the first place. Alright, let me first set up a little demo on breadboard. We're gonna need some power. Now I'm connecting two of the rails on the supply together, so we get a symmetric power supply. I've chosen plus and minus 12 volts since that is fairly standard. Okay, and let me hook it up to the breadboard. We'd want to have ground on either side. Switch the supply on. Alright, once we've done that, we're gonna need some way of getting a signal in and out of the board. I've got these flimsily wired jack sockets here that I'm going to use. Then I hook up the guitar to one of them, and a recorder to the other. Alright, that's what we're currently hearing. Then I'm going to use this orange wire to connect the guitar directly to the output. As you can hear, this is the raw signal from the guitar. Great, we've achieved nothing. But if you now plugged your headphones in, or if you just plug them straight into your guitar, you will find that you won't hear anything. That's because the signal from the guitar pickup is fairly weak in power. Basically, once you put your headphones in the loop, the pickups just can't output anything anymore and you don't hear a thing. This is where an op-amp comes in, for which I use this little TL074 chip, a favorite in the DIY synth community. It needs both positive and negative voltage. Let's now connect our signals through the op-amp. The noises you hear here are the op-amp amplifying random noises picked up by my body. Alright, I've set it up for buffering here. That means it takes the input signal and just spits it straight out, the way it came in. And tada, just like that, we hear the guitar exactly the same as before. Okay, but if you were to plug your headphones in, you would now actually get a decent signal. That's because the voltage your pickups put out is actually fairly decent for headphones. They just can't keep it up once you try to load them. The op-amp, however, has no problem driving the headphones. Okay, now let's do something slightly more interesting. I'm gonna set the op-amp up to amplify the signal. Okay, so I guess I should explain at this point how an op-amp works. Basically, it's a circuit with two inputs and one output. It takes the inputs, puts them together, and then amplifies the result by a crazy amount, usually more than like 100,000 times. Okay, but how then did we get it to just give us the original signal back? Well, you see, one of the inputs is inverted, meaning that whatever voltage the op-amp sees there gets flipped to its inverse. Thus, if we hook the output up to the inverting input, then when the op-amp outputs almost the same voltage as the input, the difference between the input and inverting input is very close to zero, which, once it gets amplified by the huge amount, is the output. We basically have 1 on the input. If we then have 0.59s on the inverting input, the difference is 0.401, which multiplied with 100,000 is 1 again. It's not quite right. We could actually take the equations and rearrange them to get the correct numbers, but that isn't really important. The point is, in practice, so long as the op-amp operates in a closed loop circuit, aka the inverting input is in some way connected back to the output, we can assume that it will do everything within its powers to make sure that the inverting input and non-inverting input add up to 0. So if you hook the inverting input up to the output directly, it sets that to the input so that they both cancel out. So now how do we get the amplified signal? Fairly simple. we use a voltage divider. When the op-amp gets half the output voltage at the inverting input, it has to push the output level twice as high as the input so that they get cancelled out again. And the same for any other ratio. So if we know how much we want to amplify our signal, we can simply make sure that the inverting input sees exactly 1 over that number, the output signal. Alright, so now let's get back to our demo. I've hooked up 2 resistors so that the inverting input sees half the output voltage and the op-amp doubles our signal. Which is why it's distorting. Let me turn down my recorder preamp. Okay, better. Alright, now I'm hooking up a potentiometer, just the same as our voltage divider before, so we can vary the amplification of the op-amp. Okay, that's still a little loud. Let me turn the recording down even more. Alright, here you can see the potting working. I turn the knob and the volume changes. Now for a little fun part. This isn't really required for an amplifier at all. I'm placing an LED into the circuit after the op-amp. Now when I plug a string, you can see the LED glowing, and the signal gets chopped in half. The LED takes off the lower half, which is why the tone changed. Now technically an LED probably isn't ideal for this. A standard diode would be better, but it sure is more fun. Alright, this is what it sounds like right now. And all of this I've put together into the final circuit design with some buffering and mixing, which I've linked below. First I solder in the IC socket, because it's large and flat and the board can lie on it. And then soldering a whole bunch of 100 kilo ohm resistors. When they get tight, I bend them like this to make them fit. And then solder, solder, solder. And snip off the legs. Okay, now I'm twisting a 100k and 27k together to make one 127k resistor, because I don't have one around. Though the exact values in this aren't that important, mostly it's just about the relations. Then come the caps, followed quickly by the LED. And at this point I had to undo some of my earlier soldering because I hadn't accounted for how big the caps are originally. Make sure to always check how many rows your components span before laying out your circuit. Alright, once that is done, it's time for all the tiny wires in the front. In places where I want to connect 2 adjacent rows, I often use snipped off resistor legs instead. Then we need to cut some traces on the back. and make sure they are disconnected. Ask me how I know. Then I solder on this connector for power, where I'm just using 2 Sony camera batteries, but basically any batteries between 5 and 20 volts should be fine. Just connect the plus on one to the minus on the other, and that middle point is your ground. And then you have the remaining minus as negative and the plus as positive. While that's happening, I'm also putting some wire on the potties and soldering them into place. This always gets a little messy. Now it's time for the case. There are already holes the right size for the potties to fit through in this plate, so I'm just drilling the small locating holes. And voila, they fit. The jack socket also gets wired and then put in a hole drilled out for it. Then, once all the other wires are hooked up, it's time for the first test. Okay, I'm not getting a signal for some reason. It turns out it's actually helpful if you put the IC into the IC socket. Okay, this still isn't what I wanted. Apparently I've built an oscillator. Interesting. Right, nothing to worry though. Let's see whether we can't fix this. Okay, so it turned out that I had accidentally bridged 2 traces while soldering, so now that is fixed. But I still don't get a signal. Time to break out the big guns! And by big guns I mean oscilloscope. Oscilloscopes are really handy for diagnosing these kinds of circuits, because you can just probe all over the place and see what your circuit is doing. And there are fairly cheap ones for around $100 that you can hook up to a computer, like the one I have, which this one is unfortunately no longer available. Alright, so the signal seems to make it most of the way around the circuit, up to the last op-amp, which really is only acting as a buffer, but here it seems to do weird things. Well, it turns out that my jack socket was bent and shorted the signal to ground, which of course led the op-amp to not have an output, because that was shorted to ground. Good, now that's sorted, it's finally time to try it out. I set this box up to take a 9-pin D-sub connector, which I've wired up to each of the pickups of my guitar individually, so that I can now put them in parallel, in series, or whatever I want. And turning up the distortion. There is this point where you can just get distortion, but it very soon starts resonating and making sounds of its own. I actually found that it helps to turn down the input signal and then turn the amplification up. noise mixing between LED and straight up amp. I find that the LED on its own can be a little harsh, but a soft mix can sound really nice. Thanks a lot for watching, and hey, why don't you try and build your own guitar headphone amp?